Jai Janendra, Namaste. My name is Sayyam Jain. Welcome to my channel. Today we are going to solve the 29th question of the problem solving series, which is based on arrays. The difficulty level for this question is hard, and this question has been asked in Amazon, Microsoft, Apple, and multiple companies. Count unique paths in matrix. So let's begin. We are given row and the column number, and we need to find the unique paths that is present to traverse from the top left corner of the matrix to the right bottom corner of the matrix. So here it's given that the number of row is 2 and the number of column is 2. That means if we draw a matrix here, so this is a matrix, so this is the top left corner, there are 2 rows and there are 2 columns, right? So here if the anyone is over in this top left corner in the 0 0 index, so to it needs to go to this bottom 1 1. Okay, so what are the unique number of paths that are present in which it can traverse from 0 0 to 1 1? It needs to go from 0 0 to 1 1. Okay, the index is, this is 0 1 0 1, right? So it is also given that we can only traverse either towards the right or towards the left or towards the bottom. We cannot go to the left part of the matrix and the up part of the matrix. We can only go to down and right. And also to give the minimum number of paths, if the distance has to be minimum to traverse from top left to the bottom right, it has to go to the right side and to the down. If it goes to left or up, it will not. So that could be a different number of possible ways to traverse. If that is the question, then it is possible. But here it's specified that you can only traverse to the down direction or towards the right direction. And we need to find the number of ways. We need to find the number of ways in which we can do this unique traversal. So if we are over here, if we go to the right and then we go to the down, we will get this path in 2 moves. Or so we move first towards the right and then down. This is one movement. Otherwise, we can also go towards the down direction second, and then we can move to the right. That is also one way. So if we go to towards the down and then we go to the right, then also we reach our destination. So we can reach our destination in 2 different ways. So our answer would be 2. So I think this is clear. With the next example, the question would be more clear. So here in this example, it's given that the number of rows are 3 and the number of column is 2. So let's draw this first. So here, okay, so number of rows are 3. These are number of rows and the number of column is 2. So this is 0, 1, 0, 1, 2. Since we follow 0 based indexing. So if suppose a person is standing over here, it has to reach to the rightmost bottom, right? It's in the top left. So how many ways it can go towards the right bottom? And so one way could be it goes to right and then it goes down down. So right down down is one way. Number 2, if it goes to down and again it goes to down and then it goes to right, it will reach again. So next is down down right. Is there any other possible way? If it goes to down and then it goes to right and then can it go to up? It can't go to up, right? it has to go to down. We only have two options. So it goes to down and it reaches this destination again. So what is the third way? Down, right, down. So there are three unique paths by which we can reach from the top left to the bottom right. So our answer should be 3. Now how do we solve this? We have this number of rows, number of columns. We need to find the unique path. We don't have the matrix. We don't need the matrix because there is no other values in the matrix. We just need to know the number of ways in which we can traverse. The other thing is we can only go towards the right direction and down direction. So what is the approach? What do you think? How can we solve this problem? So we see that from 0, 0 we are going to right, and then we need to decide every time which path we can follow, right? So and we need to find, we also have to keep track, right? That if we have followed this path, then we are currently in this position, and then where do we go, right? If we go towards we can't go to any other direction, right? Here we don't have anything, but if the matrix was bigger, then we could have gone to right also, bottom also. So how do we solve this kind of problem? So you have to identify what kind of problem is this. When there is a question of counting unique paths and when we don't know exactly, we have to remember some things, right? So we need to find the possible number of ways, and these kind of problems are actually depending upon the sub problems. Okay, so this is a big problem, right? From here you need to reach to one place, right? So in that big problem there are different sub problems, that from this place, at least if we need to reach this part, we need to go towards this direction, then this direction. So this problem can be divided into multiple sub problems. If we solve the sub problems and we continue that, then this big problem will be solved. So what do we see here? You must have heard of the topic recursion. Okay, what is recursion? When we write a function and the function itself calls the function. So suppose there is a function ABC, right? And I do a print of say 5 into if I print say 5 into 5 into any variable, right? 5 into ABC or 5 into 1, anything. Then again I call ABC, right? And say ABC is ABC accepts a integer. So if it has 5, so I can call this number as ABC into whatever the parameter it is there, 5 into 5. So okay, and again I call ABC with this value. Okay, so in this way we can this will keep on printing ABC, and then it will go and call this ABC function again, and it will print this ABC again, it will call. So basically 5 square, 5 cube, this will be printed, right? So the function itself calls the same function. So this is a kind of recursion. So I'll teach this recursion in details. I think you would know what is recursion. If not, then you need to read about it. When I'll teach the topic recursion, I'll teach the recursion concept in detail. But for now, in this example, I'll try to explain how recursion helps us to solve this problem. Okay, so recursion, to solve this thing in recursion, you need to remember 3 things. There are 3 basic steps to implement a recursion. Okay, so you need to identify the base case in the beginning. Then you need to identify the problem and the sub problem, and then you need to generalize the problem so that the sub problem solves the problem. Okay, so in this case, you see, what is we have this function number of paths, we have the row and the column. Okay, so since it is not zero based indexing, it's 2 2, that means it's 1 1, right? This is actually 1 1, right? So we are following zero based indexing. So if we have got this input, right, 2 2. So assume we need to go to the reverse. Okay. Suppose if the number of paths to traverse from this top left to bottom right will always be equal to the number of paths that needs to be traveled from bottom right to top left, and the path would be reversed, right? We can go towards the left part and the uh, upwards part, so it would be same. So if suppose from here, if I need to reach over here, right? So what is the index of this? 0 0. But here in this case it would be 1 1, because m is equal to 2 and n equal to 2. You might not understand this in the beginning, but if I will write the code, you will understand, right? So the base case is when we reach, if we are considering that we are moving from here, so if we reach this part, then that is the base case. That means if m equal to 1 or n equal to 1, so we will return 1. Okay, that is one of the path we need. Okay, and what we will do, we will call this function again, return number of paths m minus 1 n. So here we have moved towards the left direction, plus what is the other way, number of paths m comma n minus 1. Okay, and this is done. Actually our problem is solved in 2 steps. Now how did this happen? Okay, so let's take this example. Okay, we have called this function number of paths from the main, and we have given m equal to 2 and n equal to 2. Okay, now when this is the base case, this is not satisfied in the beginning, m is not equal to 1 or neither n is equal to 1. So okay, so if this number of paths m minus 1 comma n, so if this gets reduced to 2 minus 1 and 2, okay, so if we have to draw a recursive stack, recursive tree. Okay, so we are over here 2 comma 2. Okay, so what we did, this function got called again. Okay, in the beginning this got called, and it will keep on getting called, and then whatever the value would be returned, then this would be called. 2 recursion tree would be drawn, and the summation of that would be our answer. So we need to identify the base case, and then we need to generalize this. Here we have generalized it, and then we need to believe on the recursive leap of faith that this problem will be solved automatically. Let's see how this problem gets solved here. So 2 comma 2. So here this actually became 1 comma 2. Okay, the row value got reduced to 1. Again it got called, and then it actually became, it did not get called here. This is one value has come over here, right? So once this one value has, once we call this 1 comma 2, automatically this will return 1. Why? Because there is no other way, it has already reached the last row, right? The top row. Now the only way to go and reach the destination is going towards the up direction, right? So only this will get reduced. So here only we will return this one value over here. Okay. So this value once called, in the second only it returned 1. Okay. And now let's go to this direction. What we have done over here, we have reduced this 2 comma 1. Okay. So when we call this 2 comma 1, Again we have got n is equal to 1. So since n is equal to 1, 1 would be returned. Why? Why we have done this or? We could have done and also, right? But we did or. Because there is no other way. If one of them is 1, then the next way to reach to the destination is by reducing either the upward part or the leftmost part. There is no other way. Suppose if we from here it has traversed this direction. Now it can only go to the up direction, it can't go this direction. So if we get any one of them as 1, that means we can return 1. So in this way, this 1 plus 1 will give the value as 2. So this should be solved. So we have solved this problem using recursion. For recursion we know that the time complexity is exponential. Here in this case it will be 2 to the power n. Since to the power m or n, we are going recursively, and the space complexity would be order of n plus m, because we are not storing anything but there is a recursive stack. So when we study about recursion, we will understand this in details. Okay. So is there any better approach? We know that we can solve recursive problem by dynamic programming. What is dynamic programming? So here we are calling these functions again and again. So there are sub problems that will be repeated every time. So we will take extra space and we will save those value for that sub problems which are repeated, and then we will use that extra space to directly get the value and don't call the recursive functions again. So with dp, when we use dp, then the time complexity would be reduced to order of m into n. Okay, space would be again m into n. Okay, but I'm not going to solve this using dp right now. When I'll teach the dp series, when I'll be solving the dynamic programming in details, I'll solve probably 20 to 25 questions to make all the dynamic programming problem very easy. That time you will understand. So I'll solve the same problem. I think we will also involve obstacles to make it more difficult, but not now. So is there any better approach? So we have solved this in order of n square. Can we optimize it further? What would be the way? So you need to observe one thing. Here from 0 0 we are from 0 0 if we are going to 1 1. Let's not go towards the opposite way. So here, say example, from 0 0 we are going towards what is the value of this one? 2 comma 1, right? So you see the number of paths, how much we are taking. Okay, so RDD, DDR, every time we are taking 3. We are making 3 moves. Right, down, 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 right, down, right, down. So this number of moves will always have to be same. Okay. So can you, here in this case we are going right down and down right. So we are making 2 moves. The number of rows and columns are m and n respectively. So can you just see that the pattern is that we are actually making always one right move at least. If you are making one right move for this example, m equal to 3, n equal to 2. If we make a one right move, then we have to make 2 down moves. Or if we make, you see the pattern. If we have made one right move, we have always made 2 down moves. So if we are going towards the right, that is our column is there, we have 2 columns. So the number of right moves we are actually making is 2 minus 1 equal to 1. And if we have 3 rows, then the number of right down movements we are making is 3 minus 1, 2. So the total number of moves we are making is 2 plus 1, 3. That means here n minus 1 move we have more, because we have to go towards from top left to the right bottom if we are going. So the number of down movements and number of right movements is fixed, and that depends on the value of m minus n. So if m is equal to 3, then we made 2 moves, down moves, and n equal to 2, we made 1 move. What does this mean? That means we will make m minus 1 down movement and n minus 1 right movement. So what is the total number of movements we made? We made m minus 1 plus n minus 1. That means we made m plus n minus 1 movement. Here also we have made total 2 moves, and these 2 moves is equal to m plus n minus, m plus m minus 1 plus n minus 1 is equal to m plus n minus 2 moves. So m plus n minus 2, that means 2 plus 2 minus 2, that is equal to 2. So in all these examples, we are making m plus n minus 2 moves. We have to make. Now, if we have to make m plus n minus 2 moves in all the case, right? The total number of moves are m plus n minus 2. And if we in any way select any 2 down movement, then automatically the number of ways we can solve, we will get it. So here 2 down movements we have made, 2 down movements we have made, 2 down movements we have made. If we select these 2 down movements, which 2 down movements we are going to make, automatically we will get the number of moves. Simple combinatorics, right? So the second problem we can solve using our combinatorics logic, right? Total number of moves, the number of moves that we need to select, selection problem, combinations, right? So what would be the formula for the combination here? If I write the formula over here, combinatoric logic, what it would be? M plus n minus 2 C m minus 1, or m plus n minus 2 C n minus 1. So this is the formula. We need to just implement this formula and return it, and that will give our answer in what will be the time complexity? Order of m or order of n, whatever we use, and the space complexity would be order of 1. We are not going to take any extra space. So in order of n and order of 1 extra space, we can solve this problem using combinatorics. So we need to just implement this formula, and this implementation of the formula would be very simple. I would leave it to you. Try it yourself. Try to implement first using recursion. If you know dynamic programming, convert this to dynamic programming. There are 2 ways to solve dynamic programming problems. You can use the full this approach, 2D approach, where you take the full table and you keep on doing it. And there is one more approach. So we will be discussing dynamic programming in details, memoization or DP table. You can use any one of them. Otherwise, if you don't know, if you want to wait for the full explanations of my series, problem solving series, you can wait. So I suggest you to implement this using recursion, and then try to implement this formula or combinatory formula. And if you have any doubt, the link to the question has been given in the description. If you are not able to solve the problem, please come to my code walkthrough section. Here is the code walkthrough of the 29th question, grid unique path. You can see here in this LeetCode platform. I'll read out the question again. Here it is given that there is a robot of an m into n grid. The robot is initially located at the top left corner, and it will move to the bottom right corner. Given 2 integers m and n, return the number of possible unique path that the robots can take to reach the bottom right corner. Okay, and here as you can see that the movement that robot can make is robot can only move either down or right at any point of time. So we have discussed this question. So here this is the same question. You can see the second example, same example that we have discussed, and here is the code. So this is the recursive code that we have discussed how this works. So if I run this code, and we see that this has been accepted, but if we submit this, So we get that the time limit has been exceeded because the time complexity of the recursive solution is exponential 2 to the power n. So what we do, we discuss this complete combinatoric solution we can get the total number of unique steps by resolving m plus n minus 2 cn minus 1 combinatorics. So we need to implement this n plus m minus 2 cm minus 1 with our code. So this can be done in order of n time complexity, just in one single traversal, not order of n, even order of m minus 1 or n minus 1, that is order of n or m. So what we do, we know that ncr is equal to n factorial by n minus r factorial into r factorial. So n plus m minus 2 cm minus 1, the first step would be this n plus m minus 2 factorial divided by m minus 1 factorial divided by n plus m minus 2 minus m minus 1 will become plus 1. So it boils down to this n plus m minus 2 factorial m minus 1 by n minus 1. So if we expand this n plus m minus 2 factorial, so it would be 1 into 2 into 3 into n minus 1 into n plus 1 till n plus m minus 2, and the denominator would be m minus 1 factorial into n minus 1 factorial. We have expanded n minus 1 factorial, so it becomes 1 into 2 into 3 into n minus 1. So this first 1 into 2 into 3 n minus 1, the first part of the numerator divided by the last part of the denominator, they are same, so we cancel both of them. So we have currently n into n plus 1 into n plus 2 dot dot into n plus m minus 2 divided by 1 into 2 into 3 into m minus 1. We have expanded m minus 1. So if we implement this part through our normal for loop, so here in this for loop we have written for I equal to 1, I less than equal to m minus 1. So here that by we in the denominator we are dividing it by I. So in every iteration it would become 1 into 2 into 3. At the end it would be m minus 1. And in the numerator we have result into, we have result is equal to result into, so that the multiplication is every time we are multiplying it with the previous results, and we have the current value. And this we have implemented it as n minus m minus 1. Okay, so in the first iteration, if we see, this n is n plus m minus 2, and m minus 1 is minus m minus 1, and then plus I. So it would become, in the beginning, this numerator would simplify to n, and then second, every time it would n minus m minus 1 would simplify to n minus 1, and then plus I was 1, we started with 1, so it is n, then I will become 2, so it will become n plus 1, and similarly n plus 1, n plus 2, what we wanted in the numerator, n into n plus 1, n plus 2 into n plus 3, and then at the end it would be n plus m minus 2 minus m minus 1. Our I is less than equal to m minus 1, so it will become m minus 1. So at the end it would be actually n minus 2 plus m, so it would be n plus m minus 2, and in the denominator it would be obviously m minus 1, because I ends with m minus 1 is equal to m minus 1 in the last iteration. So we will get this formula, what we have simplified it to. So this simple for loop will give us the answer, so that order time complexity would be order of m minus 1. So whatever is less, m minus 1 or n minus 1, we can implement any of them. So from exponential with this combinatorics logic, it has become in the order of n time complexity. So here's the code of this, and now if we run this, we will directly submit it, and we will not get time limit exceeded. It would be giving us the accepted code result. You can see this has been accepted. So let me know in the comment section how was the explanation, and I'll see you in the next video, where I'll be explaining the last question of the array topic of the problem solving series. Thank you. Jai Jinendra.